Okay, in this last section, we're going to look at solving quadratic functions by using what's called a quadratic formula. So the quadratic formula is a way to solve a quadratic function no matter what it looks like. So we've talked about up to this point solving things by using, for example, square roots, where it's just simply the inverse operation of a square. We talked about solving things by factoring. So if I had, let's say, two terms like 2x squared minus 4x equals 0, and here I can't solve this by using a square root because I can't simplify those like terms, so instead I got to use factoring, and that counts for both factoring out a greatest common factor as well as potentially factoring out a trinomial where I would have three terms. So we talk about solving these different ways based on the type of equation you're going to get. So the neat thing about the quadratic formula is that it works all the time.
They've done studies, 60% of the time it works every time.
That doesn't make sense.
And that's right, folks. 60% of the time, this is going to work all the time. Here's what it looks like. Again, all quadratic functions in standard form are going to look like ax squared plus bx plus c equals 0. So it looks very similar to a trinomial is what we're going to have here, where in this case the a would be the 1 in front, the b would be the number attached to x, c would be the number by itself. We have the quadratic term, the linear term, and the constant term. So based on the three numbers you're given here, you're given a, you are given b, and lastly you are given c. Based on those three numbers, the quadratic formula is going to just take those three numbers and essentially give you the answer. It's just going to take a little bit of legwork from you. So what does the quadratic formula look like? It looks like this. Now this looks like a lot, and it is, okay? It's essentially filled with a bunch of numbers and operations, but you have x. So x, again, is going to be the thing we're solving for. In the end, it's going to tell us x equals possibly one number, possibly two numbers, or it might even tell us no solution. All right, but we have here first, it says negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a couple things to note. Notice you have the negative b over 2a. So that goes back to when we graphed. That's that formula from the axis of symmetry that we had. You'll notice here the square root. So it also takes into account solving by square roots, that inverse. The plus or minus. Okay, plus or minus, like we said, could be plus or the minus of whatever we're square rooting. And then you have this business inside, the b squared minus 4ac. Okay, the thing that's most important, that's unique in the quadratic formula, is this part right here. That part of the quadratic function is known as the discriminant. The discriminant is going to be this little chunk of the quadratic formula that's essentially going to tell us whether we're going to have two solutions. Like when we took the square root, we'd have plus or minus a number. Could potentially tell us that we have one solution or no solution. The reason, or how I guess we would know, is let's say that I get the square root in the end. I plug numbers in and I get the square root of some positive number. If I ever get the square root of some positive number, that means that we're going to have, in this case, two solutions. Okay, like so for example, the square root of 25, we know that's going to be plus or minus 5, and that's why the plus or minus was shown in front of it. But let's say I get the square root of, instead of a positive number, let's say I get the square root of 0. Well, in this case, I'm going to get one solution. We saw this when we solved using square roots as well, is that when I take the square root of 0, I'm just going to get 0. And 0 can't be positive or negative, so that means I'm just going to have one answer. And then lastly, if I ever take the square root of a negative number, that means we're going to have no solution because the square root of a negative number cannot happen. So this discriminant, based on the numbers a, b, and c, are going to dictate how many solutions we're going to have. So this is the most important part of the quadratic formula. All right, so now let's go through some examples on how to use the quadratic function. In this first example, what we're just going to simply look at is the discriminant part. So in example 1, my goal is just to determine how many solutions am I going to have. To determine the number of solutions, we're going to use that chunk of the quadratic formula that I highlighted. Okay, this is called the discriminant. So the discriminant is going to take our three values, a, b, and c. So in my function, a is the number attached to x squared. So in this first one, a is 1. B would be the second term, 8, and then c would be the last one, the constant term, so in this case, negative 3. So based on these three values, it's going to tell us how many solutions we're going to have. What I'm going to do is I'm going to take these three values and plug them in. So it says b squared. So b is going to be 8. So I'm going to take 8 and square it. minus 4, and when it says 4AC, that means I'm going to take 4 and multiply it by A and C. So I'm multiplying all three of these things together. So 4 times 1 times negative 3. What I'm going to do is try and simplify this then. And what I'm going to get is 76. So that would simplify down to the square root of 76. Now, 76 is not a perfect square number, so this is not going to give me something pretty. But here's the idea. 76 is a positive number. So because it's a positive number, that means that this would end up in the very end having two solutions. Okay, and that's what this discriminant is going to do, is dictate how many solutions we're going to have. Because the square root of 76, again, is going to give you two values. In this case, in simplest radical form, it would be 2 radical 19. But because we're taking the square root of it, we would think of plus or minus whatever that value is. So again, the two solutions comes from the plus or minus that we are getting from taking the square root of that number. So let's do the same thing in these next two examples. So here A is 9, B is negative 6, and C is 1. So using my discriminant, I would take negative 6 squared, and be careful here with the parentheses. You want to make sure you put parentheses around that negative 6, minus 4 times 9 times 1, 4AC. Simplifying this, what you're going to get is the square root of 0. Okay, now 0, when you take the square root of it, that gives you 0. So in this case, based on this, I would have one solution. And the reason why I would have one solution is it does not make sense to say plus or minus 0. All right, last example here for the discriminant. Here A is 6, B is 2, C is 1. Notice they are all positive. Plug them into my function. I'm going to get 2 squared minus 4 times A, which is 6, times C, which is 1. And again, I just have to simplify that. And I would get the square root of negative 20. Now the square root of negative 20, when you plug it into a calculator, is going to tell you domain error, because when you take the square root of a negative, well, that's not possible. So right here I'll see that based on this, I'm going to get no solution. So again, the discriminant, which is this part of the equation up here, or this part of the formula, is going to dictate how many solutions we're going to have. All right, so in example 2 now, we're going to put the whole thing together. So now we're going to use the quadratic formula to actually solve. So we just went through the problem on how to use the discriminant. So now we're also going to take into account the negative b, the plus or minus, and then the 2a at the bottom. First thing we want to do in this is identify a, b, and c. So just like before, a is 1, b is negative 4 in this case, and c is negative 5. So plugging this in, here's what it's going to look like. We're going to write x equals negative b. Just like our axis of symmetry, negative b means the opposite. So if b is negative 4, that means we're going to plug in positive 4. Then it's going to be plus or minus the square root of the discriminant. So that would be negative 4 squared minus 4 times a, which is 1, times c, which is negative 5. All that, again, is going to be under that square root. And that is going to be divided then by 2a, so 2 times 1. The thing we are going to simplify first is we're going to simplify this business inside inside the square root. That's called the discriminant. That's the very first thing we're going to do. So if I were to simplify that down, I'm going to get x equals 4 plus or minus 2 times 1 would be 2, and what I got to do is simplify that discriminant. By doing that, you'll get the square root of 36. Now again, the square root of 36, this is a positive number, so that means we're going to have two solutions, and the square root of 6 is plus or minus 6. So we're going to have 4 plus or minus 6 over 2. Now, where do I get my two solutions then is this. What this means, we're going to pay attention to now the plus or minus. Kind of goes back to when we solved using square roots. I'm going to do 4 plus 6 divided by 2, and I'm going to do 4 minus 6 divided by 2. That's what the plus or minus is going to tell me. 4 plus 6 over 2 would give me 10 divided by 2, which is 5. And then 4 minus 6 would give me negative 2 divided by 2 would give me negative 1. So my two answers here would be 5 and negative 1. 5 and negative 1, if you were to plug those values in for x up front or up top, you would get 0 as an end result. But I got 5 and 1 again by using the quadratic function, or quadratic formula, simplifying that discriminant, and then getting my two answers by doing the plus or minus. All right, next example, I'm going to find, again, a, b, and c to start. So here a is going to equal 1, b is going to equal negative 7, c is going to equal 12. All right, I'm then going to use the quadratic formula and plug those numbers in. And I'd get 7, again, the opposite of b, plus or minus, negative 7 squared, minus 4 times 1 times 12, which is a and c, and all that divided by 2a. Then I'm going to start off first, again, by simplifying the discriminant. By doing so, you're going to get x equals 7 plus or minus the square root of 1 over 2. Now, the square root of 1, because, again, it's a positive number, is 1. And that's, again, where the plus or minus comes in. When we take the square root of 1, we're going to get plus or minus 1, which means my two solutions are going to be 7 plus 1 over 2 and 7 minus 1 over 2. 7 plus 1 would give me 8, divided by 2 is 4, and 7 minus 1 is 6, divided by 2 is 3. So my two solutions here would be the numbers 4 and 3. So again, two solutions because that discriminant was a positive number. All right, next examples, we're just going to add some numbers in here. So notice C, my A value is not 1 anymore, but my A value is going to be 9. B is going to be negative 6, and C is going to equal 1. So again, plugging them into my quadratic formula. I would get 6, again, opposite of B, plus or minus, here's my discriminant, negative 6 squared minus 4 times 9 times 1, A and C, and all that divided by 2A, which is 2 times 9. Now I'm going to simplify this. And I'm going to get 6 plus or minus the square root of 0 divided by 18. Square root of 0 is going to be 0. So this is going to simplify to 6 plus or minus 0 over 18. But again, it does not make sense to describe it as plus or minus 0. It doesn't mean no solution, but it just means that my solution is going to be 6 divided by 18. So what the heck is 6 divided by 18? Well, 6 divided by 18 is going to be 1/3. Not a nice whole number, but it is a fraction. It is okay. So here, the only solution that would work in this problem is 1/3. I would only have one answer. All right, next example. Here we go. Here, A would equal negative 2, B would equal 4, C would equal 8. Now I'm going to plug these into the quadratic formula. I'll get negative 4, which is the opposite of B. Here is positive, so negative 4 plus or minus. Here's your discriminant. And all that divided by 2 times A, which is negative 2. I'm going to start off first by simplifying the discriminant again. And what I'll get is negative 4 plus or minus the square root of 80. Ooh. Now, square root of 80, again, 80 is not a perfect square number. So when you take the square root of 80, you're not going to get something nice. You're going to get 4 radical 5. So if I were to write this out, you would get negative 4 plus or minus 4 radical 5 over negative 4. Now, what the heck does this mean? I'll just highlight this here. 4 radical 5, again, is not a perfect square. 80 is really close to 81, and the square root of 81 is 9. So 80 being a little bit less than 81, that means this number is going to be very, 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 very close to 9. In this case, the answer would be about 8.9. So think about this simplest radical form as being a decimal of 8.9, okay? So what we're going to do here is instead of using this in simplest radical form, we're going to write this as a decimal. It's going to make a little bit more sense to us. So we're going to do negative 4 plus or minus 8.9 divided by negative 4. Okay? And what I'm going to do again is I'm going to take both of my answers would be separated by the plus or minus. So I would do negative 4 plus 8.4 and then negative 4 minus 8.4. Running out of space here, so I'll write this on the side. So negative 4 plus 8.4 over negative 4. And then I would do the same thing, negative 4 minus 8.4, and all that divided by negative 4. Sorry for cramming it in here, but I'm losing space. When simplifying both, you'd get negative 1.1 and positive 3.1. So in that case, when it's not a perfect square number, here I would get decimals. Okay, or I could leave it in simplest radical form and express it like that, but I'm not going to get a perfect whole number here when you have a number that is not a perfect square. Okay, last example here. So A would equal 1, B would equal 6, C would equal 4. I'm going to take those three numbers and plug it into the quadratic formula to get the opposite of 6, negative 6, plus or minus B squared is 6 squared, minus 4 times A times C, so 1 and 4. All that divided by 2A. You can start off first by simplifying the discriminant, the number or the part that's underneath that radical symbol. this case, you're going to get negative 6 plus or minus the square root of 20 over 2. And again, the square root of 20, again, not a perfect square, is not going to give you a whole number. So in this case, I'll write the decimal would give you about 4.47. So I'm just going to round that just for the sake of the problem to 4.5. And then all that would be over 2. Okay, so again, because it's still a positive number, it's going to be plus or minus that 4.5. We're just not going to get a pretty whole number. So I'd have negative 6 plus 4.5 divided by 2, and negative 6 minus 4.5 divided by 2. Solving both of these, I'm going to get my two answers. And I would get negative 0.75 for the first one, and then negative 5.25 for the second. So again, what we did here is we used the quadratic formula, which bases its answers on A, B, and C within your quadratic function. And again, it is a formula that can be used anytime, no matter what, to solve a quadratic. It's just the solving part is a little bit more involved because obviously we have a lot more involved in a quadratic function. So again, if you got any questions, jot those things down. We'll see you in class, and good luck.